Alright, so the question is charge polarization of CF bond is much larger compared to CBr bond. Which of the following statements in the dipole moments of CH3Br and CH3F is true? Now, for such type of questions, which are basically factual based questions, it's not easy for us to apply the formula or apply the concepts and get to the correct answer. Yes, we can get to the most plausible answer, but it can be incorrect as also. So for such type of questions, what we need to do, we need to go for the option elimination. Okay, first we need to eliminate the incorrect options, right? Then we can actually make an intelligent guess for such type of questions. Okay, because it's not easy for us to remember all the data, like for the dipole moments and for most of the inorganic stuff. Okay, so what we can do, we can actually use our concepts in order to get closer to the most plausible answer. So let's try and find out this particular question. So we have CH3Br and CH3F. Okay, so CH3 part is common, so I won't consider that part. Okay, so this is H and H, and over here we have fluorine, and for the second molecule we have bromine. Okay, so this part is actually the same. Okay, so whatever dipole moment is coming out of the part, that's going to remain same in magnitude for both the molecules. So I need to only consider this part. Okay, that is CF bond and CBr bond. And it's already mentioned in the question that charge polarization of CF bond is much larger compared to charge polarization of CBr bond. So we know electronegativity of fluorine is actually greater to electronegativity of carbon. Okay, this is very clear that electronegativity of fluorine is more in comparison with electronegativity of carbon. Okay, now over here we need to first figure out that what's going to be the relationship in electronegativity for bromine and fluorine. So if I compare the stuff, we know that electronegativity of fluorine is much greater than electronegativity of carbon, right? Am I clear on this point? So now we need to compare electronegativity of carbon and bromine. Okay, so how we can use the concept, we should remember the basic electronegativities of the general element, but let's say somewhere close to 4 we can say, right, that electronegativity of fluorine is somewhere close to 4 and electronegativity of carbon is somewhere close to 2.4, right? And if I compare electronegativity of bromine, it'll be somewhere close to, I guess, 2.9 or 2.8. Okay, so that's the value, right? Now how I can compare the stuff, see, from carbon to fluorine the dipole moment will go from positive to negative, that is towards fluorine, and in carbon also it will go to upwards direction, that is towards bromine, right? So now what I need to do in this case, I need to compare the charge polarization, which is already given in the question, that for CF bond it's more, right? The next thing is, now we need to compare the dipole moment. Okay, so we know that dipole moment is actually multiplication of your charge and distance, right? Charge and distance. So if I need to calculate the magnitude of dipole moment, we should take 2 points, that is charge and distance. And if I compare the charge factor, that's already given in the question, CF charge polarization is more than CBr charge polarization. Now the second factor over here is distance. Although with help of the first factor we can actually eliminate the options. So we know that dipole moment of CF, if I only consider the charge factor, would be greater than dipole moment of CBr, right? So first option says this, dipole moment of CH3Br is greater than CH3F. That's incorrect statement. If I go to the second statement, the dipole moment of CH3F is greater than CH3Br, which can be the correct answer. Third is dipole moment of CH3F and CH3Br are same. We cannot eliminate this option right now as of now. Let's see if we can eliminate this option or not. Okay, next is both molecules have zero dipole moment, that it's not the case. Okay, so now with the help of our basic concepts, we know that option is basically among B and C answer, so we have to actually eliminate option A and C, option A and D, right? Now again the point comes, it's a factual question, that how we can actually get to the correct answer. So we have considered the charge factor, now it's time to consider the distance factor. Okay, so if I go to fluorine, right, that's group 17 element, then we have chlorine, and then we have bromine, right? So if I compare the size, definitely size increases from top to bottom. That means size of bromine is much higher in magnitude if I compare the size of fluorine, right? It's much higher because it's, which elements. So this is basically second period element, this is third, and this is fourth period element. So definitely there's going to be huge difference in the size as such. So in this case, charge plays an important role, because what happens, yes, if I compare the charge factor, it's more in CF, but if I compare the distance factor, it becomes more in CBR. That means more or less the magnitude will be same, as if not same, they'll be, very close to close in values. Okay, so if I give you rough idea, let's say the magnitude of CF, the dipole moment of CH3F molecule is 1.69. So the dipole moment of CH3Br molecule would be 1.68 or 1.67 something, right? So that means there won't be much difference in the magnitude. So what would I say? The correct answer for this question is option C. Yes, it's a factual question, but yes, you can eliminate option A and option D. Now we have B and C, and in such type of questions, just, take some time. Do not just blindly tick option B. Yes, it's correct as per our approach, but we should understand that it's an organic factual question, so option C can also be correct answer. Okay, this might be a correct answer. So if I just think, a little bit more, if I apply my concept a little bit more, I can get to the correct answer, that yes, charge is actually, one factor, but the dominance in this question is of size, that we need to consider the size as well. So keeping all these points in mind, the correct answer for the question is option C. The dipole moments of both the molecules are same.